of this professional training on industrial electrical safety. Yes, we started this training yesterday, and I'm glad that yes, we are here today, and today is going to be the conclusive part of this training. So there's a whole lot to learn. There's a whole lot to discuss from in the course of today's class. And our resource person is here with us on board, who is going to do due diligence, breaking down and helping us to, to follow or to pursue that path when it comes to the understanding of industrial electrical safety. Okay, so my name remains Kehinde Samson Ogunmiwa, and this training is brought to you courtesy CUC Concepts Training Company Limited, like we have the name on display. Okay, so yes, like I mentioned yesterday, in today's class, at the end of today's class, we are going to be having our assessment. So let us bear that in mind. By the end of the class, the link to the assessment is going to be dropped. So please try and make an attempt at the assessment. What is required of you in the assessment is 60% performance in the whole question. So you are not expected to pass to score everything. However, we've had people who had 100% in the assessment. So you can also do likewise, can do the same. So the assessment is not something difficult. It's not outside what will be taught or what has been taught in the course of the training. Okay, so let's have that at the back of our mind. And we did promise that the requirements or the costs for the certification will be released, and we have done justice to that. We dropped that on the group, and trust me, the prices you have there are all discount prices. So please, the firm, our organization has done, our best to bring that price to such ridiculous amounts. So just try and make effort. We have the special discount that you can try as much as possible to tap into, so you can benefit from. So at the end of the special discount, the other discount offer that we have made, we are prepared, is going to take effect. Okay, so please just go through the documents we dropped on the group for more information on the cost for the training certification. Okay, so without further ado, let's go straight into today's class. We are going to be picking up from where we stopped. Okay, Telma says, hello, sir. I believe most of us are not on the group. Really? Okay, what you are going to do is I'll drop a number in the comments in the message section. So just chat that number up on WhatsApp. Chat the WhatsApp number up, so you will be added to the group. Okay, so I expect that everyone who is in this class should be on the group. Okay, thank you very much, Funke. Okay, so please, at the end of the class, we are going to be taking questions. So please, if you have your question, just signify by raising up your hand. We'll give you the opportunity to ask your question. Yes, I know it has not been easy for many people. Many people are, maybe tied up with work, so they are unable to attend this class. That's why we make available the recorded session at the end of every class. We drop the recorded session on the WhatsApp group. So try as much as possible to watch it. So the recorded session is not just for the purpose of this class alone. At the end of this class, you can go back to it, make reference to it at any point in time that you might have need of it. So if you don't have the opportunity to join this class for one reason or the other, just try to watch the recorded video. Okay, so let's go straight to today's class. Resource person, Mr. James Fanny, is here already, and in a few minutes from now, you are going to be hearing his voice. So we are going to be picking up from where we stopped. Industrial electrical safety is a whole lot. Trust me, we'll do our bit. And I do mention that this is not the end. Yes, this training is coming to an end today, but this is not the end of learning. You can't learn everything here. So just go back, make reference to the videos or the training that we offer, do your research for you to have better understanding. In subsequent days or as we progress, we are going to be dropping updates on our YouTube page, update as it concerns electrical safety and every aspect of industrial activities. We are going to be dropping them. You'll be seeing more of them. So that is why you need to subscribe to that YouTube channel So you'll be able to follow up on every of our trainings. It's not just trainings that you'll be seeing on that page, updates, trendings in the industrial sector. You will equally be getting them via that channel. So subscribe to our YouTube channel if you have not done that, so that you can follow up on every of activities as far as our organization CC Concept is concerned. All right, let's go straight to today's class. 1 minute. All right, if you can hear my voice, please just give me a thumbs up. Can hear my voice and you can see the screen on display? Give me a thumbs up. Okay, thank you very much, Emmanuel, and also thank you so much. All right, so the next voice you'll be hearing with that of our resource person, Mr. James Fanny, who is already here with us. Over to you, sir, Mr. James.
Okay, so I need Mr. Moderator, please. Can you see my screen? So if you can see my screen, so I believe that a whole lot.
Yes, please. Your screen is up. Your screen is up. I can see your screen. So I believe everyone can as well.
So you should be able to see my screen now that our moderator can see my screen. So yesterday, this is where we stopped. So we're talking about the protections against electrical hazards. So, and we explained that when we have electrical hazards, we can use insulators to protect, electrical hazards. So what do we call hazards? We say hazard is anything that poses a level of threat, to life or properties, or anything that has the potential to cause harm. So because electrical has the potential to cause harm, we say that you must be able to identify electrical hazards when you see one. We talked about overloading. We talked about not using the appropriate, tools. We talked about not using the good rating of, cables for some equipment, and the termination of, of most of the electrical installations must be neatly done so that you don't have exposed joint and all that. So that conductor material, okay, to stop or reduce the flow of electrical currents. That is what we mean by insulation. So anything that can actually oppose or that is a poor, conductor of electricity, it can become as an insulator, or we say insulation is the process that you use the insulator to protect or guide against electrical hazards. Guarding is the second one. Let me be highlighting that as I'm talking about it. So guarding, you can protect, an exposed part of an electrical equipment by guarding it. When you set a guard on it, guard means that something that can cover it so that you are practically separating the operator from the equipment. So even though it is harmful to the operator or to the person handling it, because his hands or his fingers cannot go in, or there cannot be a physical, contact with the exposed part of the electrical equipment or the dangerous part of the electrical equipment, then you have already guarded it. So that's what we mean by that. We also explained grounding yesterday. So practically we said that grounding is when you connect the conducting parts, the energized parts of an electrical equipment or of the circuit itself, electrical circuit, when you connect it to the ground. And I explained that yesterday, practically even for people that may not be electrically oriented, that it means that we are kind of producing a place of a lower resistance to the flow of current, which means that what? If you are here, there is a big door and there is a small door. Because it is very easy for you to flip open the small door, even you as a human being. So if you are this person, you will practically go through the small door because that will take you a lesser energy. That will give you, that will mean a lesser effort there for you to pull through that door. So look at electric current also like that. So electric current will also love to go through a place of a lower resistance. That is what resistance means, that from the word resist, to push back. So resistance to the flow of current is like something that can push it back, that will not allow current to flow. But if there is a particular substance that has a lower energy to oppose the flow of current will go through it. So the ground, that's the earth, okay, the ground, our ground, okay, I mean ground, is a place of lower resistance to flow of current. So when you connect down, instead of electric current, in case of discharge, in case of leakages, instead of it to flow through your body, because the earth is actually what has been made a better conductor now, then any leakage current can flow through it, and then you are protecting that kind of electrical equipment. Electrical protective devices, we also talk about that. So you can set fuses, circuit breakers, okay, ground fault circuit interrupters, which we know as GFCIs. You can set them to protect your electrical equipment. If there's anything like overcurrent, your fuse will blow out, which means that what there won't be flow of current again. Let me show us practically what the fuse does. So if I have a fuse, okay, let's say this is my fuse, and current is coming from here. So current, let's make it I, or for those that are not electrical background, let's call current. So if current is flowing like this is a device. This is the machine that we want to supply with the current. So for this machine to be powered, current needs to get down to this place. So, but instead of allowing the cable to run through from the source, this is the source of the current. The source of the current, where the power supply is coming from, this might be from your generator or anything. So the power is supposed to reach this machine. But instead of the power to reach this machine directly, we now put fuse in between. The fuse is actually in between, which means that when the current gets to this starting point, let's say this is the end point, starting point of this fuse, it needs the fuse to connect to allow it to pass through. So why do we put this fuse there? Fuse are now of different current rating. It can be 2 amp, can be 5 amp, and all that. So according to the current rating of this machine, if the current rating of this machine is 2 ampere, take for instance, 2 ampere, and the manufacturer says that anything like 2 ampere, if you have plus 0.1 ampere, plus or minus 0.1 amperes, we actually work for this machine. That is if the current gets to even 2.1, the machine will still manage that. So then that means that you will need a fuse that will show of a rating of, let's say, something fairly above the current rating of this machine. We can set it to something like 2.2 ampere. So let's say we put a fuse like this. What does that mean? It means that this fuse will not have ability to remain, intact once the current goes above 2.2. And what will happen? It will blow out. And once this blow out, just look at this, like it's being cancelled. What happened? Current will not be able to flow from here to this place again. And that's how we use the fuse to protect this particular machine. So we already said today that anything whatsoever that will go wrong for the current to actually what go higher than needed, then the fuse will what blow out. So we also have other equipment like your breakers. We have contactors, those people that are into electrical, yesterday I talked about the authorized electrical workers and unauthorized electrical workers. So you are not interacting with electricity directly in your company, but because you have to work on a machine that is making use of electricity, then electrical safety becomes something necessary for you. You need to know about it. You need to know when the electrical man that's supposed to safeguard you is doing something wrong and is putting your life in jeopardy. You need to know that when you are in the industry. That's why it's important for you to have electrical safety knowledge. You need to know when your equipment or your machine that you're operating is not safe for you to work on. You need to know that. You need to know what to do when you are to interact with an energized machine. How do you go about the line clearance? How do you de-energize it? How do you make sure that your life is safe when you are working on it? Don't forget your family, your children, your wife, your parents, everybody, every day you go to work, they are waiting at home to receive you back. So that's why you must prioritize. And I said yesterday that electrical safety is so important because any single mistake, it is an hazard that, claims life better than just leaving people with injury. When you just sustain just ordinary injury from electrical hazard, just count yourself lucky. In most cases, it's not just injury, it's life-threatening. And I showed you different rating of current yesterday that could result to electrocution, muscle contraction, burns. We talked about hacking yesterday and all that. So it's very important that you pay attention to this. Okay. Let's move. Electrically safe work conditions. What can we call or tag electrically safe work conditions? What are the conditions that show that electrically you are working safe? We have 4 of them. And trust me, every renewable industry must actually explore this 4 to safeguard the lives of the staff against electrical hazards. Number 1, look at them in blue here. The first thing is that the conductor must actually or the equipment must be disconnected from the energized parts. So which means that the machine that you want to work on, make sure that it is actually disconnected from the energized part. So this is the part where maybe you have a breaker, you put it off. Okay, that's what we are talking about. So you have to ensure that you put off the supply source. Now after I've put off the supply source, does it stop there? It does not stop there. Somebody asked a beautiful question yesterday. Can I rely on somebody to safeguard my life? Somebody from the control room? And this is where you get a deeper answer to your question. After you have put off the supply source, then you practice the lock out, tag out. You practice the lock out, tag out. Locking out means that practically a padlock must be produced for you to actually lock the breaker, the circuit breaker in such a way that nobody can have access to it. Tagging out is a paper that shows that what you are doing on the machine, the maintenance you are performing, is not an illegal work. You have a permit. So this is when you put your permit. The written permit will be placed on it. And that's what I was telling you yesterday. There is actually the challenges in our industry. In most cases, people need a routine maintenance that they're supposed to do. Your boss will need a routine maintenance that is supposed to perform on the machine, and then they want to use it as a lab rat. And so, take the risk without the permit. You can go there and just try to see what you can do. Working on a live, you know, a live circuit that you could have actually done or worked on it dead as a dead circuit. But because you don't have any, you don't want to lose their job, they have already made the normal routine maintenance, and then they want to just play hanky-panky for them to actually work on it. So he will not go there on his own, he will push you there. After that, the equipment needs to be tested. You need to test it again to ensure that there is absence of voltage. For those who have worked on some equipment that they usually have what we call residual flux or residual current. Like if you have read so much about transformer before, talking about eddy current loss, talking about flux leakages and everything, that even when your transformer has been shut down, there may still be some charges around it. Even when you think that your transformer has been shut down, like now in your area, once they take off the lights, you dare not go near to that transformer maybe in the next 1 or 2 or 3 minutes, because there will be residual flux. There have still been some, little, if you have studied the working principle of the generator before, you will understand what I'm talking about. So there will be residual flux around it. So you can still receive shock. And that is why in most industries, they will still have to test. They will carry out a test on the machine to be sure that the voltage is not present again in it. Even though you have switched off the source. You have to ensure that no voltage is actually retained. No residual current or residual voltages in it. And then you now do the grounding. I explained yesterday the difference between earthing and grounding. I say earthing is you connecting the non-conductive part of a machine to the head. But grounding is you connecting the conductive part of a machine to the ground. So that you can be rest assured that even if there are discharge or there are leakages or anything whatsoever, it will flow to the ground and not through your body. And note, in this material, I stress that all these 4 mechanisms must be used together. You don't just use one. That is when you switch off the supply, you do your log out, tag out. After doing that, you have to test and be sure that there is absence of voltage, and after that you do your grounding. Then you can go ahead and perform the job on the machine. Let's move on. I want you to look at these diagrammatic illustrations that I have here. When you follow this diagram, it will guide you on what I've explained so far. This is you just starting the job here. What is the first question you ask yourself? You ask yourself, what is the voltage? What is the voltage that I'm dealing with? This machine I want to work on, what is the voltage on this machine? So, if the voltage is less than, or equal to 50 volts, then you can perform this. You may decide that fine. If the machine is not going to be de-energized, since it's actually less than or just 50 volts, if it's not going to be de-energized, then is there any overcurrent protection on it? I hope when I'm working, too much of current will not flow through. Is there any device that is protecting myself that I'm working and the source of the supply, so that I can disengage that one and be sure that nothing will happen to me? Now let me give you an example. We call it isolation in electrical. Please, if you are not electrically oriented, I'm not here to blow grammar. I will explain to you. What is isolation? Isolation is separating somebody, right? The process of separating something or somebody from the rest. when you isolate, I believe during COVID-19, all of us, we get used to this word isolation very well. When somebody is tested positive of what? COVID-19, they'll say they have to isolate him, meaning they have to put him separately somewhere where people will not interact with him. So that is what we mean by isolation. In electrical also, you can, the best way to connect or to do your installation is to have in mind isolation when you are doing your installation. What does that mean? It means that when a machine actually is faulty, the fault on that machine should not affect the supply of other machines. In your apartment, if there are 5 flats in your apartment, that a particular flat supply is having issue should not lead us to switching off the supply of the rest of the 4 flats. So isolation helps us to do that, to show that we isolate the connection of this person from this person, so that if there's any fault, we can switch off only the one that is faulty. So as an electrical engineer, you have to study, or as an electrical worker, or authorized or unauthorized, the equipment you are working with, you have to understand how to put off the supply, even when you are there on the field. Nobody should need to be showing you around where your push button is, where the emergency switch is. Even though you are not an electrical worker, you need to learn all this. Even though you are not an electrical worker, the equipment you are working with, be concerned to know the voltage and the current rating. So if the voltage is small, you need to learn of what is the device that is protecting me from the supply, that shows that I'm not going to receive shock, or the current will not interact with me. But if the voltage is above 50, then you proceed. Do I have any exposed live parts of this equipment? Live means that live here is not, in electrical, it does not mean that somebody is alive. Live means that there is current in me. A live cable, the meaning of live cable means that there is current flowing through that cable. The meaning of dead cable or dead circuit means that there is no power supply in it. So when you have a live circuit or you have a live conductor, then this is the question you should ask. Is there any exposed? Is it exposed? The question is that is there any guard on it? If there's any guard on it, am I safe? Is there any insulation on it? So all this one shows that it's not exposed. But any of these can mean that it is exposed. If it is not exposed, that if your answer is no, then you apply good maintenance practices and protect electrical systems and parts from mechanical damage. So that will be your concern. Even though your plier has been insulated, if you do not protect it, you may not know that the insulation has caught in a particular part. I'm talking from experience. When you've been using a plier with a confidence and you just receive shock, because you do not know that part of the insulator in that plier has already been breached. That's why you see some electrical workers, even though they have the plier, they have the insulation around the plier, they will still use insulation tape. They will use it to tape it around. You will think that it is war. They will tape it around on their own again, so that they can produce more insulation and be sure that the insulation part is not breached. It's not open. That's what I mean by breach. And then you can confidently use it on an electrically energized wire or circuit, depending on the rating. Like I said, plier is not created for you to be using it on a live circuit. So that you are using on a live circuit is because you have answered this question. Maybe the voltage is so small that you can use your plier to twist. But if the voltage is above 50 volts, then you need to ask these questions. And if there is now exposed part, if it is yes, then you move to what kind of work am I doing? What's the type of work? Since it's actually exposed. Am I replacing a particular component? Am I going to remove a particular component? If I'm not removing the component, if I cannot disengage the component I'm working with, just know that you are working on an energized electrical equipment. and then you must get your permits required. So what is the permit? Permit will allow us now to disconnect. The electrical department will have to come and help you to disconnect that machine. You take your permit. And then you wear your necessary PPE, personal protective equipment. In case something goes wrong, the last man standing to the employee or to the worker is the PPE. A policeman can be trained, or a soldier man can be trained on how to lie down, how to roll, how to dodge bullets, how to fight with their combat skills and everything. But what happens if the stray bullet still comes, or you couldn't escape it? Then they wear their bulletproof, their bullet vest. They wear it. So your own bullet vest against electrical hazard and your PPE that you wear on yourself. In case something wants to go wrong, it will provide a level of safety, a determined level of safety for you. I'm still going to stress on that use of PPE. So let's move on. Now, if I'm actually replacing, okay, if I'm replacing an equipment or anything whatsoever, so equipment to be put in electrically safe work condition. So do I have to put this equipment in electrically safe condition? If I must do that, then it leads me to lock out, tag out. And then we have the summary beneath here. What does that mean? During this process, what are we doing? We are just testing to be sure. Okay? Test the equipment before you touch it. Identify the hazards. Then follow all safe work practices that are applicable to it. I've heard of a very horrible story of a man before. I think that was told to us during Dangote Academy. So it was on an Ileya festival day, and it was very popular in his environment to do all this electrical work. You know, all these guys that they are not really NEPA officials, but once there's any pra on the pole like this, they are the one that people will call. So he was called. In fact, they said he didn't want to go because he was also a Muslim and trying to observe what the Ileya, this one that they have to kill a ram and all that, Ileya festival. So that they approach him that those people are not comfortable that there's electrical fault. So they will not use the power supply to do Ileya, to be boring and all that. So they were mounting pressure on him that he should come and help them. And many of us, if you have undergone a single facing fault before. Now, what is that single facing? You may be seeing it in your area. You see there were 3 lines from your transformer. A line completely will be out. Another line, their power supply will be full, their voltage will be very high. Okay, and you see the other ones that also have their voltage will be very low. They will have low voltage. So that was the scenario of what really happened. So he had to go to the transformer to work. So he was so angry, was so pissed off that they disturbed the Ileya festival that he just wanted to do it. He was not happy with it. And when he got to the transformer, the first mistake he made was to put his hand on the body of the transformer. What was the issue? I wanted to discuss. You know that overconfidence, okay, talk to me. What was this? What was the problem? And that was it. That was it. That was the last thing that he ever said. So you need to be sure before you touch equipment. In fact, sometimes when I'm working on anything like electrically energized, people are quick to say, "Hey, are you not an engineer? Is that not what you study?" It's not about that. You trying to actually prove a point to people. When you work as an electrical person, if you are really electrically oriented and you know the safety of electrical work, then you need to work differently. There must be difference in the way you work. It must be different from somebody that just say, "I have an idea." Because you know the danger. You know what could happen. An electrically oriented person or safety person would not place a bet on electrical work. Do that. I can touch this cable. Put your money. In factory, when I get to train factory workers, I warn them against betting. There are a lot of them that bet. They bet their life on safety. I've heard of somebody before who bet with his colleague, and the compressed air that they are using to blow their body in the plant, he bet that he can put it inside his mouth. And that other one also say, you dare not. And they place their bet. And he put the compressed air, the hose of the compressed air in his mouth. And also allow the other person to be the one to even open the what? Open the head. So that one opens to a very high pressure. And that was the end of him. So you can't gamble with an electrical work. You can't say you can seize your breath. I will seize my breath and then I will touch the cable. You don't. Because even electricity, we all have the story of Faraday himself. Electricity is not a respecter of anybody. So do not put your life in danger and the life of people that are working with you. I talked about hacking yesterday. I talked about this. So now let's look at the permits. Okay. So in the permits, I will still elaborate more on the permits, but let me move straight to electrical safety controls and requirements. So what are the electrical safety controls and requirements? Okay. So we said electrical equipment must be free from recognized hazards. Yesterday, what we first did, part of the thing that we trained on was how to identify hazard. I told you that if you cannot identify what is wrong, then the lot is wrong with you. You need to identify what is wrong at your place of work. Even after this training, you need to go back to drawing board and begin to see part of the installations in your industry that are giving rise to electrical hazard. See, on a more serious note, they may look dormant. It may be, they will tell you, we have been using it for 7 years now. There's nothing wrong. Haven't you been using it? That you have been using it for 7 years or thereabout does not make it right. It is a danger or an hazard waiting to be activated. And when it's activated, you won't be there to control it. So we must know that what cables exposed to what sharp edges, you have to check them. These are electrical hazards. When you have a cable that is passing through a sharp edge, I don't know if any of us have experienced it. Over time, when you pass that cable on that sharp edge, it will be what? It will be cutting through. It will be cutting through. It will, especially if the part of the machine, if it is close to a moving part of the machine, all those cables, all those terminals, all those terminations that are close to the what rotating part of a machine must be carefully guided. You must make sure that what they are not cables do not what pass through what the sharp edges that can cut them down to the what conducting part. What about splices? I'm going to show you about what splices. That is when you are connecting two terminals together. Dear conductors, do you have such dear conductors in at your place of work when you have what? A cable is coming, another cable like this, another cable is coming like this. Okay, this may be the red, black, and then they will not twist this mouth together. They twist this mouth together, and they leave it like this. The only thing that they just separate it, they will make the red mouth to go towards north, and this one will go towards south, and you now hang it there on the wall or in your place of work. These are the things we are talking about. They are wrong. That's a dear conductor. Any single mistake, somebody can just laugh and forget himself and just do his hand like this, and then he will receive it. If the insulation is not intact, that's another thing. So you see some people, because they want to justify that they can do it, they now put black tape around this place. That one will be hanging. The black tape might even be the one that has lost the magnetic part of it or the gummy part of it. So it's not really sticking. It's not really sticking to the conductor again. So they just use it to cap the mouth. I've seen somebody using nylon as what as that. I've seen people using nylon to wrap this mouth like this. Nylon. That is poor. That's against electrical safety rules. You use nylon to cover what and a conducting part of a wire. Or you are using an insulating material that does not stick to it. In fact, it's even wrong. You have to rigidly tape it in a way that no. Nobody should touch that joint and receive a shock or a threat, an electrical threat. So all these must be highly noted. Unused openings must be effectively closed. See the beautiful thing that many of us normally, I see some people thinking that, sometimes you think that it's not useful. When you look at your sockets, okay, this is the bolts, this is the place where you screw it in. You will now see they will put a cover. It used to be in orange color. They use it to just stock it in. You know that this particular place is actually the bolt that you use to screw. Mind you, there are some deterioration that can occur that when you put your tester around here, you'll be seeing that there's current there. That is why the manufacturer produce those particular covering to cover it. They are unused openings. Every opening that you know that they are not in use is a future threat. If not today's threat, it will be a future threat. You have to cover it. Look at this. Something like this that I'm zooming here. All these openings, something like this opening here. You have to cover this opening. Look at this place that I'm circling here. You cover it. Look at the dangerous connection here. Leaving cable hanging like this or using this kind of tape. These are the hazards that we are talking about. They are wrong. Okay. Labeling requirements. For every piece of electrical equipment, okay, that you know that it may need examination, you may need to adjust it sometimes, you may need to service it, you may need to maintain it when it is energized. You have to label it, okay, and you have to follow the manufacturer prescriptions or the guides of the manufacturer. You have to follow it, okay. Which means that you must know the voltage, you must know the current, you must know the wattage, you must know all the necessary ratings that are there so that you know what you are dealing with. Okay. So of course, you will have the material. Look at the splices we are talking about. You see the right way to join cable. Look at this. This is a splice. So using a splice rather than using a tape. Okay. Many of us, if you go to in your industry, definitely this is what you will see splice being used. Once you join two cable that both of them need to conduct, you put it there rather than for you to use this tape. This is safe. Using splices is safe. Using this is against safety. This is against safety, electrical safety. Okay, as I say, yes to this, no to this. So you must join the splices mechanically, and it must be electrically secured. It's very, very important. Now don't forget that we are talking about electrical control. Okay. Look at the grounding. I explained this also. I've been explaining it. So you see the picture of grounding here. So we connect to the earth. So this is the connection to the earth. You can see that it went into the soil. So that if there's any leakages of currents from the conducting part of the machine, what will happen? It will flow to the earth and make the worker safe. It is very, very important. What does this actually offer? It protects you against shock. Leakage current can make you to receive shock from the machine. Fire, okay, and equipment damage. Yes, it can also make the damages on equipment due to current leakages and all that. And we also have the power stress that the path to this earth that we're talking about must be a permanent one. Look at this. This is a permanent one, ever continuous with the flow of current, and it must be effective. So these are part of the inspection that you should do on every equipment that has been installed. You need to work from, adequate time to time to check their earthing and their grounding if it's still intact and properly done. Now we are just trying to differentiate here. Okay, what we mean by grounding and what we mean by earthing. So when you talk about what I explained that yesterday, when you talk about grounding, the energized parts, okay, connected to the ground, that is what the grounding. In fact, it helps in so many ways. If you in your industry you must have seen a lightning arrestor, okay, it also helps in that. So you can connect down even from the lightning arrestor. You can connect a lightning arrestor, connect it down to the earth, so that if you are working in an high-rise building, all these 7-story, 10-story building and all that, or some high building in your factory, there has to be the lightning arrestor being connected to it. And what it still also does, it is grounded. So it's the conducting part or an electrically energized part exactly connected to the ground. And you can also do earthing of that equipment also, meaning that the body that you think that is not a conducting part, if anything go wrong with the installation of the equipment, there may be conduction. So for you not to take that risk, even the part of the machine that you know that it's not meant to conduct electricity, you need to ground it. You need to connect it to the earth. And that is earthing. So another thing I want to show us is for you to have the identification of grounding conductors. Okay? You know, I've been mentioning two things. You can ground, you can earth. Grounding, earthing. Earthing is the one of the non-conducting parts of the machine being connected. Non-conducting parts, meaning that you need to identify the wires or the cables when you see electrical wiring. So when you see the electrical wiring, you see that part, the cable that is green, maybe yellow, okay, stripe, or the one that is bare. Those ones are the ones that are connected to the non-conducting part of the machine to the earth. But the one that is connected to the conducting part is the one that you see as white or gray. So you can see them here. Okay, the one that I'm actually zooming in. Please, if you are with me, let me check up on us. I'm checking up on you now. If you are with me, please go to the in message and type yes. Type yes, type yes, type yes. Okay. Thank you. Thank you so much. Yes. Thank you so much. Thank you so much. Yes, I have a lot of people alive with me. Okay. That's fantastic. Thank you. Okay. So I've talked about GFCI. Okay. I've talked about all these. So the hacking. Okay. So you can have all these, Now, another thing is that some people normally ask me questions, and that's why it's very good for us to stress this aspect of Lotto. So you see, Lotto is not about Jebu. Okay, the Lotto, the first LO means lock out. You are using a padlock, okay, on the circuit or the breaker that is supplying a particular machine, and your tagging is that you are putting your paper permits on it, so that even if we have somebody that have the spare key, he thinks that, oh, who locked this place? Who locked this place? You want to use the key to open. He can see the paper. Please, men at work on so equipment, do not energize. Now, it is your right when you go to the electrical department for them to actually carry out, because it's the electrical department that I know popularly, you shouldn't conduct Lotto on your own. You have to go to the right department, which is usually electrical in every factory. Maybe during the question and answer, a lot of people can tell me their experience about the way it is being done in your industry. But normally it's an authorized electrical personnel that will follow you to the breaker of the machine. So when they lock out the machine, you have the access to the key. The key of that padlock should be with you. You should have the key with you. And that's where the question of yesterday
is deeply answered now. You are not trusting anybody. The key of the lock must be with you. It is when you are done that you submit the key that now you can go and open that place. A copy of your permit, as it is being put on the what breaker where the padlock is being used, a copy should be with you also. We have seen the situation where the electrical make mistake and they will claim that the person did not come for permit, and they will remove all the traces of evidence. The only evidence with you is the paper that shows that you truly went for that permit. So it should be with you. So you can see how you cannot trust anybody when it comes to your safety. You can't trust anybody. The only person you can trust is yourself. By doing what? So that's why there's some work. Like when we are those people that attended the occupational health and safety, where I talked about I talked about personalizing your own safety. You have to personalize your own safety. You have to know that what safety begins with you. Your safety begins with you. You can't hand over your safety in the industry. You can't hand it over to another person. So in that training, I talk about JSA, that's job safety analysis. It is the people, the team that want to work on a particular task that will perform DSA. And what is the meaning of DSA? DSA is for them to go and identify all the hazards they are open to. Nobody can do that for you. You are the one to do it. You are the one to work there. So we can only trust you that you will do a thorough job. And if anything now go wrong, then you blame yourself that you are the one that did not do a thorough job. You are the one that put your life at risk. So specific procedures to safeguard employees from the unexpected energization or startup of machinery and equipment, and from the release of hazardous energy during service or maintenance is what we call LUTO. So LUTO is that procedures that will ensure that there won't be an emergency start up when you are working. So you must complete your LUTO awareness. It shows that every employee in the factory must learn how to recognize LUTO and how to undergo LUTO requirements. As an employee, I must know when a sign that shows that people are working on a particular machine, that they already collect permit. That is the only thing that can give me knowledge that I should not go and start a machine that people are working on. So it is very, very important. So that is LUTO, okay? Also, we talk about space around electrical equipment. That is part of the safety, okay? You can relate that to the isolation that I also talk about. So electrical equipment must be rightly spaced, in between, okay? So proximity must be such that encourage safety. So it is very, very important. Guarding life paths, I've talked about that. Okay. All right. So we have done a lot of justice to this particular material. Then we can, I've talked about circuit breakers. Okay. I've talked about GFCIs and all that. Then we can now go to the part where we'll be talking about the PPE, personal protective equipment. Now, in this personal protective equipment, I'm not actually talking about the general one. I want to kind of, take it down, narrow it down to only what is applicable in electrical safety. Generally in safety, we have what we call PPE, that's personal protective equipment. And we say that it is an equipment which is intended to be worn or held by a person at work. Many of us that are here already know what PPE is. What I'm here to do is to actually to give you the practical implications, pros and cons, let me use that word, of PPE. PPE is not meant for you to rely on 100% that you are safe. There is no PPE that gives 100% safety. It is just providing a level of safety to you. PPE is not the first approach to achieving safety at work. It is only the last resort. In case, if anything should go wrong, let this be the last resort. I cannot overemphasize that. So, when you are protecting your hand with hand glove, electrical hand glove, that's to protect your hand, you should know that the electrical hand glove you are using doesn't mean that you go and be touching live cable. I saw somebody who was actually doing an electrical installation, and the circuit is actually live. There is current flowing through it, and because he wear glove, he was using ordinary hand to twist the cable together. That is a wrong practice. You can't use your hand to do the work of a plier. I have seen people who are, they have been doing electrical work for quite a while, and they still use their teeth to pin wire. Whether the cable, whether the circuit is live or dead, it is a wrong practice for you to use your teeth to pin wire. You need to practice with using your plier. For me, practically as I'm talking to you, it took me a while. And because I'm exposed to the safety part of it, I had to actually adjust. You will now see that when you practice using plier, you will see that there is no faster way you can pin a cable than using your plier. So people believe that their teeth is faster. What happens if you think that the circuit is dead? Just imagine yourself mistakenly putting a live cable into your teeth that you want to peel it with your mouth. In the industry then, I still remember back then in Dangote, I have a special knife. The handle of the knife is insulated, very well insulated, that if there's not a cable that maybe your plier cannot do, you can just like you want to sharpen an arrow, or you want to sharpen a stick, okay? You can use that knife to peel the cable. Just use the knife to peel the cable. That's for you to ensure that a conductor is not to interact with your teeth, whether it is dead or alive. A lot of medical practitioners may even be telling you germs and everything. In this kind of case, I'm not even talking about germs. Even though germs and bacteria and all that is still part of the safety, that anytime I'm training people that are medical, workers like doctors, nurses on the safety aspect of their job, we get to narrow down to the one that is affecting them, which is germs, bacteria, viruses, and all that. But in this case, I'm not even talking about the germs and bacteria that can enter your mouth using your teeth on a live cable. I'm talking about the electrical, hazard, because this is electrical safety. What happens if you receive shock in your mouth? I've seen people, if they want to test a dead battery, they put it on their tongue. They will use their tongue to taste it like as if they are tasting yogurt. That it is when it shocked them in their tongue, they say, oh, there's still charges there. It's a wrong practice. There is nothing like that in electrical safety. You have to find a way of testing a circuit that is live, and not by using your teeth. So your hand glove must be an electrical hand glove and not the mechanical. You should know that we have mechanical hand glove and we have electrical hand glove. The electrical hand glove is made of rubber. Mechanical hand glove is made of wooden clothing material. I have had somebody before during the training, it was a physical training anyway. He shared his experience, how he mistakenly used, or somebody at his place of work used a mechanical hand glove to do an electrical job. That is suicidal. That's suicidal. It is better for you to even do electrical work with your bare hand than for you to mistakenly use a mechanical hand glove to do the job. Because in mechanical hand glove, if you have used such before, there is no way you will not sweat. And that's why we use the rubber for the electrical work. Because when you sweat inside, Okay, the rubber, your sweat cannot be absorbed by the rubber. So the rubber is still an insulator that will protect you. But even though the clothing material or the woody material of that particular mechanical glove can still protect you, when you sweat to it, your sweat is a better conductor of electricity. Then you practically electrocute yourself. You expose yourself, you open up yourself even faster than or better than you using a bare hand to do that connection. That's number one. Now, for some people who have actually seen electrical hand glove also before, you will see that they have a different level of thickness. When you check the one that you use on a single phase, like a 220 to 240 volts, okay, when you check the thickness is always different from the ones that you see NEPA officials use. There are some NEPA officials that sometimes they get to actually work on a cable. Perhaps it might be the distribution line that is not transmission line. Okay, if it's not transmission line, if it's just distribution line, the one that is coming from transformer, maybe all those ones that are just single phase and everything, there are some, glove that some of them actually use. Okay, not practically using their hand on the live cable, but even when they are using the plier and everything, their hand is actually protected to some extent. Okay, so the thickness of those hand gloves are actually different. Now, what about the goggle? In case you are working and then hacking and all that. So look at the electrical goggle. It's quite different from the mechanical, and it's not a fashion shade. You will see why it's not a fashion shade. What normally differentiates electrical goggle is this aspect that you are seeing here. Just look at my red pen. This place I'm pointing at. That is the side shield is what actually will tell you if what you are wearing is electrical. The side shield means that it protects, it encloses your eyes. We just want to practically enclose everything on your eyes. Look at the top shield. The top shield. This is not it's not usually in your fashion goggle. It's not there. We want to practically enclose the eye so that if there's any splashes or any flash or hacking, your sight can be protected from burns. So it is very important. So it has adjustable arm. Look at the adjustable arm. Okay. Look at the one that is protecting you with against a fog. Okay. Here is the frame. Here is the bridge that sits on your on your nose bridge. Okay. So these are PPEs. We have clothing. Yes, we have electrical clothing, such that will not encourage it has a level of resistance to fire outbreak. If you use ordinary clothing material to do electrical and there's fire outbreak, it easily catch fire. I don't know how many of us that have attended practical where they use a fire blanket before. We normally use that in our practical. So when you look at all these kind of blankets, relate it with some of these electrical cover. There are electrical jackets, there are electrical cover. All these are just material that they have a level of resistance to being burnt. They have a level of resistance to it. So it's not like you will do electrical work and there will be fire outbreak and your clothes will just catch fire and then it starts running up and down. So there are clothing that are just cover that you use generally as place of work, and there are electrical ones. Okay, there are such that are electrical ones that have a high resistance to fire outbreak. So another thing you must notice that there are some electrical job that requires you providing a respiratory protection. Okay, for people, especially those people that do underwater welding. If you are going for an underwater welding, okay, many of them go in with their own respiratory system like oxygen. There are people who do confined space entry work, confined space. Okay, confined space mean that is a place that you want to perform a job, and the place has a limited entrance and exit. Sometimes it is what the place that you enter through that you will come out through, and only one person can bodily enter the place. So there are so many of jobs like that. Maybe they want to clean the pipeline. Those people that are working oil industry and all that. So confined space entry can also, if you are going to perform the electrical job in there, we have to actually test the air there. Will there be any fire outbreak maybe during the job that you are carrying out? If there's a little spark, can it result to fire? If there's limited oxygen there, you have to go in with your respiratory system and all that. So this is on PPE. Now let's move very fast because I really want to target, stopping early enough. I want us to interact. I want questions to come out. There are some questions also here I will bring up for you, and then I will have people who are trying to give answers to them. So let's talk about basic fire safety. It is very necessary for us to talk about fire safety when we are talking about electrical safety, because most dangerous fire outbreaks in industries are usually caused by electrical hazard. And when you have fire resulting from electrical hazard, it is not like when clothes or paper, if they are burning. No, when you have an electrically energized equipment caught fire, then you need the skill of basic fire safety for you to fight that fire. Now, the first thing that you need to know in fire safety are the components of fire. If you don't know what fire is, then how can you protect your equipment or protect yourself against it? So you need to know what fire is. So this training is opening you up that fire is not just fire, but fire is made up of 3 components. And what are these components? The component is the heat that needed to be generated. We call it combustion temperature. Every equipment has a temperature, the level of temperature that they will burn. Okay? So if they do not reach the combustion temperature, they will not burn. You have the fuel that the fire is feeding on. And then you have the oxidizing agent, which is the oxygen. These 3 things must be present before fire can be said to have been completed. And locally, I can prove that to you. Yes, it's always there. Look at your matchstick. Our matchstick that we normally use to light up in those days. Okay, I hope we have the generation that use matchsticks because it's enough of a lighter now. Okay, so this that is clothed on his mouth is the fuel. The oxygen is always present around us. It's always there. So fire have access to oxygen anywhere. In fact, oxygen is always a readily available material for fire. The heat is what we want to generate. In most cases, you now take your match box, you'll be producing friction between this matchstick and this box. There are sometimes when you see that the friction is not enough, fire will not be produced until you are able to produce enough. You scratch it against the box such that there will be friction. And once there is friction generates heat. So there will be heat that will be provided, and then fire will result out of that matchstick. So for every equipment that burns, just know that there is heat, there is fuel, there is oxidizing agent, which is oxygen. Now the fuel is always there for fire also, just like the oxygen. Anything whatsoever, anything that is referred to as matter can burn. It just needs its own combustion temperature. Anything can burn. Human beings are fuel for fire. Your clothes, chair, pencil, rug, kerosene itself, all these, they are the petrol, gas, they are all fuel for fire. They are always there. Your electrical cable is a fuel for fire. It can burn. TV set, radio, phone, shoes, everything, they are fuel for fire. And that is why it is very important for us to know that if all these things are fuel for fire, Then do we fight fire that is burning, with clothes, and another one that is burning with what? Kerosene? Do we fight them in the same way? The answer is no. If clothing material is burning and another one is petrol that is burning, you will practically see that it's two different things that are actually burning. And then that leads us to talking about what classes of what fire, or classes of what fuel in relation to fire. So we have the class A. The class A type of fuel are the wood, paper, clothes, trash. We call them solid combustible materials that can burn. The materials that can burn, that are solid, they are the class A. The class B is our flammable liquids. Okay, liquid or non-metal combustible material that are in liquid state, like your kerosene, your gasoline, your oil, your grease, your hailstone, all of them, they are under the class B material. If you are with me, please let me see your thumbs up. Just ring the thumbs up for me. Thank you so much. Thank you so much. I love the energy you guys are giving me. Thank you so much for sticking with the class. You are doing fine. Now the class C, that is our own bone of contention in this training. That is the electrically energized equipment. Electrically energized equipment. Now let me note this. Do not say that there is no power supply. Then you say that is not electrically energized. In as much you see the cable of an equipment being plugged in. Look at this word. As long as it is plugged in, we don't want to know if the socket is dead or if there is a live, if it's live, if the current is flowing through it or not. No one cares. What we care about in electrical is that in as much you see that it is plugged in, consider it as electrically energized material. Why are we doing this? So that you do not make a silly mistake. A mistake that can cost you a lot. So in as much it is plugged in, consider it that fire is being produced by electrical source. Class D is the metal, maybe potassium, sodium, when they are burning. We hardly interact with this. Now, let me explain the concept of fire extinguishers. Now, what is the fire? What's the concept? When you first look at the grammar, when you extinguish something, extinguishing something means that you want to put out that thing. You want to kill it. So fire extinguisher means that the devices that we can use in killing fire. Now, you must know the kind of fire that you want to kill. Am I killing the class A? Am I fighting the class B? Am I fighting the class C? In this training, our focus is on the class C. But for the benefit of you understanding class C, I will briefly mention class A, I will mention class B. Now, the concept of fire extinguisher, don't forget I told you already that fire is made up of 3 components. So since we have 3 components of fire, the idea is that if you can attack one of the components, then fire will be out. And that's very important. If you remove it, only the fuel and oxygen cannot produce fire. So there are some fire extinguishers that are made to attack, their own is to attack the fuel. They can separate the fuel. So the heat and oxygen that will be remaining, they cannot make fire, so the fire will go out. There are some fire extinguishers that are built to attack the heat in the fire. So if the heat is being brought low, if the combustion temperature, which maybe is 10 degrees Celsius, and you can bring it low to 1 degree Celsius, then the fire will be out. If we have another fire extinguisher that is to attack the oxygen, Once we can separate the oxygen, then the fire will actually be killed and it will be extinguished. So it's very important that you note all this. So based on this, that's what makes us to discuss different types of fire extinguishers. We have the air pressurized water fire extinguishers. Now, one of the practical ways for you to play safe is that when you see a fire extinguisher, focus on the labeling on it. The labeling on it, they always write it there. Now, the only thing that must be in your mind as a safety person, safety-oriented person is that you must know the classes. The class A is for solid combustible material. The class B is for liquid combustible material. The class C is the electrical material. So when you know all these, in this class A, you will see class A being written on the on that fire extinguisher. So you don't just carry a fire extinguisher and start fighting fire. You need to know what is burning. What is burning? When people tell you that fire, you need to know what is burning. When you know what is burning, you know that it's class A fire extinguisher I can use. Because when you use a wrong fire extinguisher on a wrong type of fuel that is burning, you can make a terrible mistake and make the matter worse. From today henceforth, your own approach should be different from people here that will fire. They start mentioning, okay, carry sand, carry omo, carry water. It is not every fire they use that for. And I've witnessed a lot. Some people here can also share their experience. When you are using water, you are pouring water on a fire that is burning with kerosene or petrol. you are making a terrible mistake. In fact, the more you pour water, it will be as if you are making the fire angry the more. So don't have that notion that it is water that always kills fire. Who tell you that? It depends. If it is class A, so we call it air pressurized water. So this kind of fire extinguisher, about 2/3 of this fire extinguisher is filled with tap water. The rest is just air. And then you can use it to fight class A. If the cloth is burning, you can use it. Slippers is burning, you can use it. Paper is burning, you can use it. Okay, foam is burning, you can use it. Carbon dioxide extinguisher. Now, another practical thing I need you to be noting is that these air pressurized water extinguishers. Mr. Moderator, please, I need one person to give it a try. Nothing difficult, please. It's just for you to give it a try. Moderator, please. Anybody that wants to answer my question, don't worry, just try. The question I want to ask you is that which part of those fire do you think that, which component of fire do you think that fire extinguisher is actually fighting? The air pressurized, I told you that it contains only water. So raise your hand if you are ready to talk. Moderator, please select somebody for me.
Okay, so just signify if you want to ask a question. Okay, Chimevi, Acho. Yeah, good evening. I feel
so which component of fire do you think that this fire extinguisher is attacking? Is it the heat? Is it the fuel or the oxygen?
It's attacking the fuel.
How is it attacking the fuel?
For the water pressurized, for example, it attacks the wood of fuel, which is the fuel in that case, which is solid fuel.
Okay, that's your opinion. Thank you so much. Thank you so much. Is there anybody that have another opinion before I actually now make my own comments?
Udoji Sylvester.
Yes, of course I have it.
Please go ahead, sir.
Hello.
Please go ahead. Is that Udoji Sylvester?
Yes. For me, I see it as the fuel there is what is the water is attacking.
Okay.
The fuel
okay.
is what the water is attacking.
It is the heat for me.
Is that Olaoluwa?
Yes.
Okay, thank you.
Your lad, I can see your hand.
Okay.
Your lad,
Sir, I think. Hello, sir.
Yes.
Good evening, sir.
Don't forget. Let me list out what you are to mention. Is it the heat? Is it the fuel? Or is it the oxygen?
From your explanation, I think the air pressurized fire extinguisher is meant to attack the heat as one of the elements.
Thank you very much. The air pressurized fire extinguisher is only bringing the heat low, is reducing the heat, therefore taking out the fire by reducing the heat. Now, let me give you a practical explanation of that. Many of us have tried this. For many people that use stove to cook before this gas of a thing becomes so rampant now. In those days, okay, Geolite, are you still there?
Yes, sir.
You use stove, right? You used stove before?
Yeah, I used to.
Okay.
Before I started
Okay.
using
So has there been any situation before that you try to put out the fire after you have finished using your stove and the fire is proving stubborn? What do you normally use to put out the fire?
Honestly, it is a very risky situation. Sometimes I apply water.
Okay.
I apply water after lowering it to the PRS minimum, and it refuses to go off. Sometimes I apply water.
Okay.
To take the flame.
It's not good for the maintenance of the stove, right? But you know that when you use water, okay, and you don't just pour water, you have to use energy in your hand to maintain the pressure of that water on it. Okay, so the water is just to reduce the heat because of the wick, those things that are burning in the stove. Okay, once the water pour on them, in most situations, when water pour on your stove, you know that you are not using that stove for the next 1 day. You have to bring it to the sun and all that. So the air pressurized fire extinguisher is attacking what? The heat. So it's a practical way for you to be noting this. Now, the carbon dioxide extinguisher is used for the type B and the type C, which is class B and class C. What does that mean? It means that if you have to fight fire that is burning, maybe kerosene, that is burning, maybe your diesel, that is burning petrol, or electrically energized source, then you apply what? Your CO2 fire extinguisher. Now, it is very important. CO2 fire extinguisher actually stand out. It's very easy for you to identify it, even without checking the labeling. CO2 always have a large horn. There's a large horn, okay, on the CO2. You see it. It's the only one that normally has the large horn. And aside the large horn, it is the only fire extinguisher that does not have a pressure gauge. There's no pressure gauge on it. Because the pressure in there is very, very high. If you have used it before, in fact, once you actually energize it and you discharge it, you see how chilly, cold the mouth of the fire extinguisher will be. So the CO2 is used for class B and class C. So you practically see the labeling. But sometimes it's always good for you to check because you can see class B. When you see BC, that means that it can fight the electrical source and can also fight the combustible source. Now another person. What is CO2 fire extinguisher? Which part of the component of the fire is the attacking?
Okay, Popola read one. Popola read one.
Is that what? Thank you so much. So you remember redox reaction in chemistry. So it's attacking the oxygen. So it's reacting with oxygen. Once the oxygen is actually brought out.
What about the reaction? So
hello. Hello.
Please go ahead, sir. Go ahead, sir. Please, if you want to answer any question, just reply. If you want to attempt any question, just signify. I will call on you. Thank you very much. You can go ahead, sir.
Okay, I can go ahead, right?
Yes, you can.
Yes, sir. Go ahead.
Okay, thank you so much. Okay. If you have the the CO2 is actually what attacking what the oxygen part of the fire, and therefore leaving the fuel and leaving the heat alone. Now, the third one is dry chemical extinguishers. Dry chemical is so effective. This is the type that you have in your car that is encouraged for you to have in your what, kitchen, in your house, and everything, because it's a fire extinguisher that I refer to as a multi-purpose. Okay, it's a multi-purpose. How is it multi-purpose? It can fight what? Class A, Class B, Class C. But you need to check the labeling. There are some dry chemical fire extinguishers that only fight what? BC. They design it for only BC. You can luckily see the one that is what? ABC, but most cases is ABC. And that's why it is the type that you are encouraged to get in your car. Because in your car, all the 3 classes of fire I've mentioned now, they are present. The chairs inside your car, they are Class A that can burn. So you need a Class A fire extinguisher in case of fire. There are wires, okay, connection. Your battery is there, that's electrical source. Okay, the combustible is the fuel, your petrol. So these 3 things are present in your car. So you need to get a fire extinguisher that can fight the 3 classes of fire. So you can tell me, what do you think that the dry chemical, the chemical, when if you have seen where it is being used before, the chemical is just like like powder, okay? So it's just powder that is actually discharging, but with high pressure. So that's what we call it dry chemical. Which part of the fire do you think that is attacking? Anybody?
Philip Slavo. Philip Slavo, I can say.
Yeah, it reduces the fire from getting to the fuel. So it cuts down oxygen to ensure that it doesn't get to the fuel, but the fuel will ignite or further damage the fire.
You have practically answered it. It separated, it isolates the fuel. That's what it does. It will clothe on the fuel. That's why if you see dry chemical where it is being used, if this is the cloth that is burning, you see dry chemical, powder will be on it. So it's just practically like the food is there. You are poisoning that food for the fire. So the fire cannot interact directly with that fuel again. It cannot interact with it, it's clothing it. So his own is to attack or separate the fuel from the fire that is burning. Now, what are the points for you to remember when using your fire extinguishers? What is the guide? It's very important when you are using when you are talking about fire safety. So the rules of firefighting, okay, we learn it alongside with this. Number 1, when fire is burning, you must actually sound the alarm. If you are in the factory and you see that there's fire outbreak, help in sounding the alarm. Let people be aware that there is fire outbreak. In some industry, there are fire alarms that they have. However, if the fire alarm has not been activated, maybe the smoke detector has not detected the smoke, or there's any fault, sound the alarm. Let people know that and every worker in the industry must know the sound of the alarm, fire alarm. They must be aware. That's why internal training is very important. You must know the sound. When you hear the ringing of the fire alarm, you must be able to identify that, this is fire. And then you start running to the muster point. We call it muster point, or you call it assembly point. Okay, this is the place where everybody must gather, okay, for head count. This place, all the employees will gather so that we can count them and be ensured that nobody is trapped inside. As you are sounding the alarm, if you don't have electronic alarm, use your mouth for the alarm. Turn your mouth to the alarm. Start shouting. Let people know that there is fire outbreak. Let people know that there is fire outbreak. Shout fire, 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 fire. Let your mouth do the job of the alarm. In case there's no electronic alarm. As you are shouting that, start leaving the building. When there's fire outbreak, that's not the time for you to remember the document in your drawer or anything whatsoever. your life first before the property. And then you call the fire department in your place of work to alert them that something is actually what's going on. One thing you must note about fire extinguisher is that fire extinguisher is only encouraged to be used on small fire. You don't use it to fight, or when they say a particular building or a section of your place of work has been engulfed with fire. You don't use fire extinguisher to face it. When fire is just starting, when it is small, you can use fire extinguisher. Now, many of us may not know how to operate fire extinguisher, but if you listen to me attentively in this class, you should, be able to interact with your fire extinguisher. When you remember the acronym PASS, then this will guide you. The first thing is for you to pull the pin. So when you check your fire extinguisher mouth, you will see what? A pad, like a pin on it, okay? I'm zooming this for you to see. So the pin is always around this place, okay? So you pull it out. You pull out the pin. After pulling out the pin, you aim your fire extinguisher, that is the mouth of this, like this one you are seeing, that this is a dry chemical, okay? So aiming is that what? You remove this mouth, you aim it to the base of the fire. So when fire is burning, if this is what is burning, okay, this is fire, smoke is always up here. What many people normally commit as a mistake is that they direct the mouth of these hose. They are fighting the flame. They are not fighting the base of the fire. You need to attack the fuel, the source that is burning. So this is the wrong way to put your hose, but this is the right way to position the hose. You aim it to the base, okay? And when you aim it to the base, then you squeeze the handle. This is the handle of the fire extinguisher. You press this handle together, okay? Don't apply too much pressure, because if you apply too much pressure, you won't be able to control the amount of the material that will be coming out here. So you press it lightly, and then you start spraying side by side. You sweep your hand. In other words, the fire that is burning may be as large as this. So it will not be good for you to just point the hose here and you're just attacking this place alone. No, as you are pointing, you'll be going back and forth. You'll be sweeping. Sweeping means that what? Let your hand go through this length, come back, go like this, come back, go like this, come back. You sweep it. You sweep your hand, okay? And then you practically use your fire extinguishers. So it's very important that what we take note of that. Now, another thing is that what you should know that what these are the characteristics of fire. Fire is always very fast. You can't predict, especially electrical energized fire is usually fast. And the problem is that many people don't always know what to do in the case of electrical fire. In the case of electrical fire, the first thing for you to try to do is to see if you can put off the power source. And that is where isolation comes in. Power source, putting off the power source will help you to lower the risk when you are fighting fire that is electrically energized. So if there's any source supplying that particular unit in your factory, and that is why whether you are an electrical man or not, you should know the breaker. I've mentioned that. Know the breaker that are supplying your machine. Once your machine is at the risk of fire outbreak, the first thing to go and do is to go and put off the source. Put off the source, and then you know that what you are fighting now, it has reduced to either class A or class B. And then you can confidently use your dry chemical powder fire extinguisher on it. So there won't be more spark. If it's a spark that is actually causing that fire, imagine that you put out the fire, the spark also occur, fire start again, you put it out, fire start again. But when you put off the source, there won't be spark. You can practically go a bit closer, some distance to the machine, and point your fire extinguisher and start fighting. Okay? So fire is usually fast, fire is usually dark. People don't see clearly when they are in a burning or building or burning department or anything whatsoever, and fire is hot. In fact, the smoke coming out from fire has a tendency of weakening you. So In the case of you coming out of the building engulfed with fire, you should practically go down as low as possible as you can. Because many people, what they do is that they tend to panic and they will be running through the fire or be running through the smoke. Inhaling the smoke will weaken you. So because smoke is less denser than what clean air, so the oxygen that you need to breathe must have sunk down. It's actually beneath the ground. The smoke is the one that will come up. So if you can practically go down, you can go down on all fours, like your knees. You are crawling on your knees. It will allow you to breathe some cleaner air, and then you crawl out of the building. And if crawling is endangering you again, you can actually lie flat on your stomach and be dragging yourself out, just like that. And practically, as you are dragging out, we always explain. If it's a practical demonstration, I will show you. Okay, let me just explain it. If this is you, practically lying down on your arms, when you move some distance, 1, 2, you crawl 1, 2, raise your arm, flip it side by side to check for any obstacles on your way. Checking for the obstacles on your way is for you not to run into what? An open blade, an open electrical source, or anything whatsoever that can hit you. The worst thing that will happen to you is for you to have another impact on your head when you are trying to escape from fire. So you should not rush out, but crawl like 2 steps forward. Then you use your arm to check all around you to know if there's any dangers that you can run into. Another thing we normally train people on that because in companies, we go to companies to train them on how to leave the building whenever there is fire outbreak. Okay, we call it escaping drilling. Okay, so if you want to leave the building where there is fire, then you need a lot of skills for you to leave. And part of these skills will also allow you to help people that may need your help to leave the building or to escape the building. That's if you practically know that you are already safe. Now, how do you help a colleague, maybe somebody that is that have some disability, okay, a pregnant woman or anything whatsoever in fire drilling, okay, you can actually see how you can actually do this. So I'm trying to go as practical as possible. So when you want to leave the building, let's say this is you in a particular ward. Maybe this is your staff room, okay, or this is the store, or you are working in this unit and you heard a fire alarm that there is fire everywhere. So this is the door, okay, that leads you to another building here. So we always explain that do not rush up to open this door. You never can tell if fire has engulfed this place. So do not rush up to open the door. In fact, do not use your direct palm, the palm of your hand on the doorknob. Because if fire has engulfed everywhere and the doorknob is red hot, that will lead to burning your palm. So you use the back of your hand to first feel the doorknob, just touch it lightly to know how hot it is. The same way you touch you test if a pot is actually hot in your house. That's what I'm talking about. So just touch it lightly to see if it's too hot. If it's not too hot, then there's possibility that the next room is actually safe. And even when you are opening it, you should don't open the door just like that. You open gently, because in the case of fire incident, if fire has engulfed the next room that you are going to, as you try to open the door, the fire will attempt to seize the door in your hands and rush in. So you open it lightly. Once you see that fire wants to escape in, then you close that door. You know that cannot be an escape route for you. But if you open lightly, you see that, no fire is actually, so that means that the next door might actually be safe. So it is very important. The drilling, usually, if you have gone through this drilling in your company, you can actually share with us. So Mr. Moderator, let me stop there. I've, touched the necessary things that needs to be touched. And then if we have questions, and I will be glad to actually welcome your questions. Thank you so much for staying with me, everybody. It's been a very wonderful journey with you on this electrical safety. Thank you so much. Thank you so much. Thank you so much. Thank you so much.
All right. Thank you very much, Mr. James, for that very, very engaging session. We appreciate you a whole lot. Just a minute. Okay, so let's quickly take questions. Let us take questions. So please, if you have questions, you have your comments to make, just signify by raising up your hand. I'll call on you. So let's do that quickly. Questions, comments. So those who joined us via the YouTube live, you can as well drop your question in the comment section. Okay, someone is asking that what is the difference between earthing and grounding? Yeah, I suppose the trainer already asked. The trainer already said a whole lot regarding this. I think he talked about grounding and earthing yesterday, and he equally mentioned it in today's class as well. Anyways, okay, so what is GFC? That person is asking what are the characteristics of fire? Okay, I think all these things we mentioned during the class. Okay, so but nevertheless, we'll give the resource person the opportunity to respond to those questions. Okay, please, if you have any other question, just signify. Okay, Mr. Udoje Sylvester, you can unmute your mic, sir. Okay, sorry, Mr. Udoje Sylvester, you can unmute your mic. Okay, Mr. Udoje, I seem not to. Okay, I can hear you now. Yes, you can go ahead, Mr. Sylvester. Mr. Sylvester, you are not audible. Okay. All right, my apologies, Mr. Sylvester. Sorry, you can unmute your mic now. My apologies.
You have deactivated my mic for long.
Yes, so sorry. You can go ahead.
Yes, my question is, can please, you should talk a little on this LOTO concept in the procedures that involve in this LOTO concept in safety. Hello?
Okay, Mr. Sorry, I was trying to sort out something on my device. That's why I couldn't quickly unmute you at that time. So please,
is my question noted? My question noted?
Yes, can you repeat that? Can you repeat it again?
Okay, my question is that, when he was explaining these practices in safety, he mentioned the word LOTO, L-O-T-O, as a key concept in enhancing safety. So my question is that, can he please explain a little on or mention some key steps that are involved in this LOTO practice in enhancing safety in electricity?
Okay, thank you for your question. Thank you for your question. Do you have any other question? Any other person? Before we bring back our resource person, do you have any other question? Okay, just a minute, let me check our YouTube if we have questions from that end as well. Okay, so far, okay. So let's bring back our resource person, Mr. James. Mr. James, over to you, sir.
Yeah, thank you, Mr. Kende. Thank you, everyone, for being on board for this training. Let me just go straight to the point. Somebody was asking about the difference between grounding and earthing in the course of the class. Perhaps you're having some network issue. When we talk about earthing, let me give you some illustration. So I hope you can see my whiteboard. So let's say I have an equipment, and this is the casing of the equipment. These are the connections. Perhaps it's a single phase. We have the live coming in, okay, and I have the neutral, okay. So the conductor itself, inside the conductor itself, if I connect, the conducting part, that's the conducting part of this particular installation. If I connect the conducting parts, that's the part I know that current can actually flow through. Okay, so if I connect it to the ground, that is grounding. Grounding is when you connect the conducting parts of an installation. But normally, I'm not expecting any of these for us to have electrons flowing through this body of the casing of this installation. So the casing is just an house. It's just to house it. So it's called a non-conducting part. So these non-conducting parts, there are some cases that can have us that can make a leakage current to actually still find its way to the body of these installation. If you study transformer very well, so there are some non-conducting part of the transformer that due to flux leakages, so there may be some flux leakages that will still make those parts to actually conduct. So because of that, you also see that the body, you always see it in this sign. When you see an installation, you will see this kind of sign. Okay, so this is earthing. So earthing is when you connect the non-conducting parts to the ground, and grounding is when you connect the conducting parts to the ground, all for the sake of what? Safety. So that is in the case of that. Somebody was asking about the fire characteristics. I mentioned some things as such. When you're talking about characteristics, that might actually be different from the constituent of fire. So I talk about the constituent of fire. I said that we have the fuel. Okay, we have the fuel, we have the heat that we call combustion temperature. So every materials have a combustion temperature at which they can actually burn. So, and then we have what? Oxidizing agent, or we say oxygen. So the fire must feel on something, must breathe, and must have what? Heat, okay, to some level before it can actually what? Burn. So these are the three constituents of fire. Now, what are the characteristics of fire? Fire grows very fast. Fire grows very fast. Okay. The fumes, that is the smoke coming from fire, can actually sedate you. That is, it can make you to fall into what? A deeper sleep. That's why some cases you hear some people putting on their generator overnight, and the fire would break out, and then they will still be in that deep sleep when the whole house is actually what? Engulfed in fire. So the smoke can make you really go into deeper sleep. It can grow very, very fast. It is hot, so it's not predictable. Small fire now can grow into what? Inferno within a few minutes. So those are the characteristics. Okay, it's very fast. So knowing the constituents will make you to actually know that fire would be out when one of these constituents is out. So the concept of fire extinguishers is that there are some fire extinguishers that are built to only take care of the fuel That is, they are going to isolate the fuel. Okay, they are going to clot the fuel. In the case of the dry powder fire extinguisher, so what it does is it will isolate, it will separate the food, it will take the food away from the fire, and fire will die naturally. There are some that their own is to attack oxygen. So they attack oxygen, like the carbon dioxide, the CO2 fire extinguisher. It will attack the oxygen. When it reacts with oxygen, what happens? The fire will die. So once the water high pressure water fire extinguisher. So the one that's the one that attack heat. Okay, when you are using water to fight fire, what you are attacking is the heat. So when you bring down the combustion temperature, so the fire will naturally die. So that's what you have. Somebody was asking about GFC. GFC simply means ground fault circuit, and that is why we have interrupter. So ground fault circuits, what are we talking about ground? So it is not expected, okay, that current should actually what flow through some parts. So that's the ground part. So it is not expected that what there are some parts that it is not expected that what current should actually flow through it. So when we have current flowing through these parts that we do not intend for current to actually flow through, then we say that what we have ground faults. Okay, so the fault is called ground fault, and that particular circuit, that particular unit that what current is flowing through, that's what we call ground fault circuit. So in the shorter form, you will have GFC. So in case of this, because this may actually occur in any installation unexpectedly. Oh, I don't want current to flow through it particularly. It's not, that part is not for current to flow through. It's supposed to be a safe part, but yet current in the case of fault, flow through it. So we have what we call GFCI, that is ground fault circuit interrupter. So that one is to arrest, okay, is to interrupt in the case where we have what current actually what flowing through that place, is to cut off. Just like somebody is supposed not to pass through a particular gate, you have given an order, don't pass through these gates. But you now put a soldier at the gate that, oh, in case this person is adamant and he now want to pass through the gate, so you should be the one to stop this person. That is what an interrupter actually does. So about Lotto, I explained Lotto. Some people even will call it Lototo. Lototo. You may also have it in this form. The LO that we have is, okay, let me write it this way. So we have Lotto, and then in case you now have Lototo. So we have lockout. You lock out. This one means tag out and test out. So in other words, what it means is that whenever we want to work on a particular equipment, of course, this equipment is actually supplied by a breaker. Okay, let's say this is the equipment and this is the breaker. The breaker means that where the electric supply is actually coming from. So in most companies, you have to go to electrical departments and tell them that you want to perform a maintenance on this particular machine. Because you want to perform maintenance on this machine, what Lotto simply regulates is that we don't want incidents, electrical incidents, in the case of somebody working on a machine and mistakenly somebody power up that machine. Somebody supplied that particular machine. So you go to electrical units or whatever may be the due process that you have in your company, you go and meet them that you fill a form that, oh, you want to work on this particular equipment, tag number, so it must have its own tag number, and then they take you are to be present. So don't take Lotto in a prosy, in absentia. You have to be involved. So when you fill the form, there will be a copy. It's just like you go to bank, when you fill your teller, you know there's always this duplicate. So there is always duplicates in that particular form. They will give you a copy, like the bank normally give your own receipt as an evidence. So you have a copy to yourself that's an evidence that I came legally and formally to inform you that I want to work on this machine. They will also retain a particular copy, and there's another copy that they will take. So both of you, you and the personnel that want to carry out this lotto for you, will follow you. And then when you get to the breaker, that's the breaker that is supplying the equipment, they will remove this breaker. When they remove it, the lock, the tag, the paper that you fill is what we call the tag. That paper is what gives evidence, just like the way you normally see on the road. Workers are on men at work, keep off, something like that. So that's the paper that carries that, oh, there is a particular maintenance going on this machine. So they will put that paper, there must be somewhere here that they will put that paper. Just for anybody, they will hang the paper there so that anybody that is coming here will know that this breaker was put off so that these people can carry out their maintenance. Now, the paper is not enough by experience. There are still some people who are crazy enough to be angry that this particular unit is supposed to be functioning now. Why we just put paper there? And I'm telling you, they will start up that particular equipment. So that is why we have lock. Lock is like your padlock. So after they put this paper there, the breaker is also being padlocked in such a way that you that want to work, you have the key to that padlock. It is when you are done that you're going to bring that key so that they can open this particular breaker and put it up. So we are using lock and we are using tag to secure this particular breaker so that people that are working on this equipment can be safe enough to work on a dead circuit. In fact, there are some all these air breaker, all these big air breaker, they will still even edit it for you. They will edit it for you so that in case of leakage current, there shouldn't be any feedback to you on the field. Now, the test out is that there are sometimes that people will think that they have already done the lotto and it's not perfectly done. So the electrical personnel will still help you to test it out. That is, they will test it out. That is, testing out means cross-checking to really be sure if the lotto process has been correctly done, so that it will not be an assumption that, oh, don't worry, the circuit is dead, and then you go on site on the field with the confidence that, oh, I'm working on the dead circuit, and boom, you have the feedback to yourself. So that is what lotto means, and that's the brush through all the questions I could capture. Thank you so much. Over to you, Mr. Moderator.
All right. Okay. Yes, thank you very much, Mr. James, for your response to those questions. Yes. Okay, so the person who is asking that what type of fire is class fire extinguisher can be used for class D. Yes, your class D, you can use your dry chemical fire extinguisher for your class D kind of fire. Okay, so let's take note of that. Okay, so thank you very much, everyone. We have come to the end of this training on industrial electrical safety. So like we did mention, we are going to be dropping the assessment link on the WhatsApp group. Let me see if we can drop it, in this in the in-message. Let me see if I can lay my hands on it. Or probably we'll drop it on the WhatsApp group. So please, you're expected to do a performance of 60%. Attempt the assessment. It is important that you do so. So please, let us take note of that. And trust me, the questions there are questions around all that has been taught. Okay, so as for the certification as well, the payment for the certification is ongoing. So please try as much as possible to tap into the opportunity of the discount, the special discount offer we have. The discount offer is going to end the 28th of this month. So try as much as possible. If you have any maybe issue, what we just do that we permit, even though yes, we are trying as much as possible to bring the price as low as that, is that we give you the opportunity to do it in 2 installments. Yes, for those who who cannot pay at once, so you can do it in 2 installments. So reach out to the group admins. So please, let's be careful. Let's watch out. There are a lot of scammers on the groups that we can't really control. But trust me, if you must relate or communicate with anyone regarding your payments, follow the information that the admins drop on the group and communicate with the admins alone. Avoid giving your information to anyone or calling anyone that is giving you a personal account to pay you to. Avoid such. So don't deal or relate with such. The admins are the only ones that will reach you. And yes, in some cases, you get calls from maybe officials of our company. They will properly identify themselves, and even if they will give you any information, it's going to be related to what you have on the group. So let us take note of that and beware of scammers. They are everywhere. Okay, so I want to say thank you to everyone who has been a part of this learning journey. So please subscribe to our YouTube channel. We have loads and more trainings coming up. Yes, still in this month and in the months to come. So we have trainings that are definitely going to unfold, and you can equally have access to them like this for free, like this. So subscribe to our YouTube channel. We are going to be dropping the YouTube link as well. Just hit the subscribe button so you can have unrestricted access to many of our videos and our recordings and our trainings as well. Okay, so I want to say thank you to everyone. But before we leave, let's just take one person to give us their feedback on behalf of the class. But please, your feedbacks are very important to us. Go on the WhatsApp group, drop your feedback. Yes, we need a detailed feedback from you. Yes, these are part of the ways we promote our businesses. And I would equally like to state, yes, we are a company, we are into trainings. Perhaps your organization or your firm needs, a training partner that can partner on a particular aspect of training. Just feel free to reach out to us. We love your connections. So if you can connect us, yes, we'll be so glad. We can schedule live training like this for your company, your organization, live trainings like this without even coming to your places. Yes, we do that with companies that are outside Lagos or outside Abuja, where we have our strengths mostly. Okay, so please reach out to us and feel free to communicate with us. Yes, we are in business and we are ready to deal or do business with you. Okay, so please, before we leave, Abel Elijah would love to get your feedback on behalf of the whole class. Can you please do that for us? Mr. Abel, you can unmute your mic. Let's just have your feedback. Abel Elijah, can you hear me? Okay, let me get Mr. Richard Kofi from Ghana. Mr. Richard, can you unmute your mic and give us your feedback?
Yeah, hello, boss. Hello.
Yes, Mr. Richard, please go ahead.
Hello.
Yes, Mr. Richard, please go ahead.
Okay, thanks to everyone in this class today. Thank you too for your good things that you have been doing. Okay, this is the second time I'm part of your training, but since I've joined your training, I've learned a lot, and I know that things are there, many that I'm in need. So I'm giving thanks to you too. Hello.
Thank you very much, Mr. Richard. Thank you very much, Mr. Richard.
Hello. Yeah, so I can encourage everybody that you have to be joining your class anytime, anywhere that you have to come online to teach us anything that you teach us, because there are a lot of things that I did not cross it about. Actually, but since I joined this training, I've learned a lot.
In no time. Mr. Alonso, I can see your hand. You have a question for us?
Yes. Moderator, thank you very much. I was in and out because of the office meeting, but later I know I'm going to rewatch the video clip for the training today. It's very good. The training is nice, but I will advise you guys, if you can go out there, because there are a lot of young engineers, there are a lot of young guys. Safety is one of the things, because me, I'm a safety supervisor in one of the reputable company. So I know how many times people meet me and ask me where can they do safety course and all that. So I don't know if you can maybe collab with maybe an NGO or something, or I don't know, any group, to bring this thing out there, so that since to me the amount of certificate is in fact you can't get it anywhere, that amount. So if you bring it out there, maybe somebody can say volunteer to pay for 3 persons. Somebody can volunteer to pay for 4 persons and all that. And a lot of people will benefit because safety now is one of the top priority in our industries now. And when you preach more, when you educate people more, and a lot of people also use it to get job. Like me, that's what I did. I know I have about up to 9 to 10 safety certification now. I study biochemistry, but I'm not working with biochemistry. I'm working with safety that I did. So I don't know. That's my advice. If you can bring it out there so that the young graduates will benefit. Thank you.
Thank you very, very much, Mr. Emmanuel. And also, yes, we can't really overemphasize the importance of safety, and that is one of our goals and targets, to be able to help many professionals in the industry to be able to meet up with the demand, with the safety demands across the industries. Yes, we are doing our bit. This training is not just the end of the safety training we're doing. There are other batches that will be coming up, and that is why we are reaching out to you as well. You can make those connections and connect us. Yes, we are if it is training, so far it is training, we are always ever ready to deliver. Okay, so please, you can reach out to us if you have people, groups that you have organized, companies, associations that we can relate or collaborate with, that we can that needs our expertise when it comes to professional.
So if I may ask that, where's your location?
So the next time we like this, we are still going to be communicating on the group. So I wish you all a productive weekend, because it's almost the weekend. So I wish you a productive weekend ahead.
Sorry, sir.
Thank you very much, everyone.
Can I ask?
Where's
your location? Port Harcourt, Lagos, or Abuja? Can you hear me, sir?
You can unmute your mic and tell me bye-bye.
Can you hear me, sir? I say, where's your location? Port Harcourt, Lagos, or Abuja?
Pardon?
Where's your location? Location. Is it Port Harcourt, Lagos, or Abuja?
We are in Lagos.
Are you in Port Harcourt?
Bye-bye. Thank you very much.
Thank you. We are in Lagos. We are located in Lagos. Just look at. We can continue our discussion on the WhatsApp.
All right. Thank you.
Okay. Bye-bye.
Okay.
The assessment edition will be dropped.
Yes, it will be dropped. It will be dropped shortly on the group. It will be dropped.